Welcome to all. Myself R. Vivek, Assistant Professor in Mechatronics Engineering, K.S.Rangasamy College of Technology at Tiruchengodu. In this video, I am going to talk about the subject is machine design. I already posted two videos for unit number 1 and unit number 2. If you are not watching that video, kindly go and watch that videos. This video, I am going to talk about unit number 3. Unit number 3 is springs. So these are the topic I'm going to cover these topics in this video. First one is spring and what types of spring, and second one is design of leaf spring, and third is design of torsional springs under constant loads and varying loads, gears, types and terminologies, design of spur gear and helical. Yeah, spring is defined as an elastic body whose function is to distort when the load and recover its original shape when the load is removed. Application of spring is to cushion, absorb, or control energy due to the either shock or vibration as in cause. Springs, railway buffers, air draft, and landed gears and shock absorber and vibrations. To apply the force and the brakes, and clutches and springs and loaded valves, the control motion by maintaining contact between the two elements as in the cams and followers to measure the forces as in the spring balances and the engine indicators to store the energy in watches or toys, etc. So spring is nothing but we all know that it is a elastic body and the load is applied on the spring, it compresses, and when the load is removed, it again retains the original position. These are all the few applications of the springs. So here I am showing the uh, helical spring diagram. It is a open helical spring is two types. First one is a open coil, and second is a closed coil. The first diagram shows the open coil, second one is a helical springs. Same. The advantage of helical spring is easy to manufacture and available in a wide range and reliable and have a constant spring and characteristics of a various changing the dimensions. This is a conical and valve spring. The first diagram shows the conical spring, and second diagram is a valve spring. Used in a special applications where telescoping springs are a spring with a rate increases with the load is disordered. Conical springs wound with a uniform pitch. So it clearly shows the characteristics of a conical spring. And second one is a valve springs wound in the form of a paragraph with a constant pitch and a left angle. The number of active coils gradually decreases and the number of coils decreases in the increasing the rate. So conical and valve springs are is specially used for special applications. This is a torsion springs, may be defined as a helical or a spiral type. So look at this diagram. It shows the if you look at a spiral one. A helical type may be used in many applications only in a load tends to wind up a spring are used in a various electrical mechanisms. It is mainly, it clearly shows that it is mainly used as a electrical uh, applications. So this is the leaf springs. The diagrams, this shows the leaf springs. So like these springs are laminated springs. It is called as a laminated spring. Also known as a flat spring, a coverage springs, a constant number of plates uh, of varying lengths together by means of clamps and bolt. So these are the springs. They varies length to clamp the bolt. This is a leaf spring or a disc or belief springs, a constant number of conical discs held together against a slipping a central board or a tube used in the applications rates and compact springs are used. These are the wide used spring for the heavy load vehicles, leaf springs. You all see for a truck or car minimum four-wheeler vehicles are using leaf springs only. So the end connections of compressed and helical spring shows the It shows a plane end, it's a ground end, and third is squared end, and fourth is a squared end and ground end. These are all the parameters we all must know while designing the helical springs. So stresses in the helical springs of a circular wires. So D stands for a mean diameter, and small d stands for a diameter spring wire, and N is number of active coils, and G is modulus of rigidity, and W is the axillary load, and tau is the maximum stress. We all know shear stress, and C is the spring index, and the P is the pitch of the end coil. So next one is spring deflection of the spring. While designing the helical spring, we all must know these parameters. So springs, the four diagram shows the torsional shear stress and direct shear stress. So while torsional shear stress, the how the torsional shear varies with the load, corresponding load, and this diagram shows the direct shear stress with varying the load. This This is buckling of compression springs. In order to avoid buckling of springs, it is either mounted on a central rod or located on the tube. When the spring is loaded on a tube, the clearance between the tube and walls and the spring should keep as small as possible, must be insufficient to allow for increases spring diameter during the compression. So in order to avoid the buckling effect, the central load or central rod or which is located on the tube to avoid the buckling. So buckling of compression spring is hinged end spring and the built-in end spring. The first diagram will be hinged spring and second one shows the built-in end spring. So this is the leaf spring. So cross-sectional area of the leaf springs. So for first diagram shows the cross-sectional area of the leaf spring, and second diagram is the bending stress of the diagram, and the third one is the shear stress diagram. According to load, it varies. For general, in general, this is the bending stress diagram and shear stress diagram for leaf spring. So here the diagram clearly shows about leaf springs. Clearly shows we all definitely we are watched this type of spring in all vehicles. So master leaf has to withstand a very vertical bending load as well as a load due to the side weight of the vehicle and the twisting. Due to the presence of stresses caused by these loads, it is usual to provide to full length leaves, rest grounded leaves. Rebound clips are located in terms of the intermediate position of the length of the spring. So the graduated leaves are the sharp to shear in the full of the lens. So here the diagram, the first in the previous slide, the diagram shows the first length, maximum length of the spring is called as a master leaves. So this is the equalized stress in the spring leaves. It is called as nibbing. So stresses in the full length leaves is 50 percentage greater than the stress in the graduated leaves. All the leaves should be equal stress in leaf springs. So we definitely note these 2 points while designing the stress. The first point is the final stress is the leaf is also equal to the stress in graduated leaves due to the applied load pulse in the initial stress. The deflection in the spring due to the applied load is same as without initial stress. So while designing the leaf spring, to find the thickness of the leaf, so these are the formulas we are going to use. So to find the length of the spring and the number of graduated leaves and bending stress. And second formula will be deflection of the springs. And this one to find diameter of the eye for leaf springs. So these are the formulas which we are going to use to find out the diameter of the eye. So last, to find the length of the leaves. So these are the formulas we're going to use: length of the smallest leaves, length of the next leaves, similarly length of the n minus nth leaves. D stands for inside diameter of the eye, and small t thickness of the master leaf. So I hope I give some ideas about the springs. Definitely, it will useful to you. So thanks everyone. So keep learning and growing with K.S.Rangasamy College of Technology. Thanks for watching once again.